Hello, and thank you for joining this video where I want to describe to you some of the features of the PhD proposal, development and evaluation of clinical decision rules for early diagnosis of cancers with application to high-dimensional data from breath testing. I'm Linda Sharples. I'm the main supervisor for this PhD, and I've got co-supervisors Ruth Keogh and Tom Cowling. So let me tell you a little bit about the proposal. Cancers that develop in the alimentary canal, things like the esophagus, the pancreas, the liver, and the rectum, they're often difficult cancers because they have symptoms that are not specific, things like pain and fatigue and that kind of thing, which could mean lots of different things. They're diagnosed late, and because they're diagnosed late, there are limited things that the clinicians can do, limited treatment options, and that means that the outcome is poor because they're diagnosed in the later stages. So we need a new way to diagnose these cancers at an earlier stage. Okay, so we've been working with scientists and physicians at Imperial College on some breath tests. And these breath tests are based on the fact that the tumours themselves release cells, and those cells travel through the blood system into the lungs and are breathed out as what they call volatile organic compounds. So they can pick up these compounds within the breath. And those the breath can be analysed using a mass spectrometer to try and extract all those things. So it's a way of having a non-invasive test to try and identify people who have cancers in these in the digestive system. There have been early experiments on patients who have cancers in the esophagus and stomach, the pancreas, the liver, and the colon and rectum. All those things have been studied separately, and so this is what we call a receiver operating curve for colorectal cancer. And in all those cancers, we found that the breath test had a very high sensitivity and a very high specificity. That means if cancer's there, we've got a very good chance of detecting it. And if it's not there, we've got a very good chance of ruling it out. And at the moment, large confirmatory studies are going on, and we're accruing a lot of data in all those tests, for all those tests separately. And what we do in the London School is to contribute the statistical expertise to those experiments. So what this particular PhD is about is joining all together all those separate tests and trying to create something which is one single test, so that we can diagnose cancer overall for those sites in the body. And then once we've identified a high chance of cancer, then we can try then to decide which is the most likely one of those, and therefore which of the pathways patients need to go down in order to get the fastest diagnosis, the fastest definitive diagnosis. What we would do is to look within this PhD is to look at the methodology for creating both the overall test and the test which allows us to differentiate between the different cancers. So if you're a first-class student, ideally with an MSc in statistics or medical statistics, but you may also have other expertise or experience which is equivalent to that. So we're looking to attract a wide range of applicants for this PhD, so that we can choose the one who's most promising and has most enthusiasm and interest in this kind of project. So if that sounds like you, please come and join us, because I think it's going to be a really exciting few years. Okay, thanks very much for your attention.